In the next set of examples we're going to be considering, we would like to consider a case where we're adding and subtracting rational expressions in which both the fractions have one denominator that is a factor of the other denominator. To motivate that, we might need to revisit the concept of least common denominators of two numbers where one number can divide into the other. In which case, observe that for 7 and 14, the big number is the seed in this case for your thought process. And how do I mean it is the seed? It is the first number you should check whether it can be the LCD of both numbers. So let's say that we want to check if 14 is the LCD of 7 and 14. Well, 14 always divides into itself, so that is a one-off immediately. But we have to check 7. Well, 7 also divides into 14 without any remainder, so it checks out that 14 would satisfy the requirements of a LCD for 7 and 14. Why is that important to us? Because in the next part of the question, which is to find the sum of 1 over 14 and 2 over 7, it will make our life a lot easier. If we know the LCD to be equal to 14, all we have to do is to find a way to ensure that both denominators match the LCD. Well, it appears that the first denominator here already checks out, so there is no work to be done. We do not need to put any extra sauce on this particular fraction. It's already in good order because its denominator is exactly the same as the LCD. However, on the other hand, this fraction, 2 over 7, is not in a good form yet. We would really like the denominator to match up to 14. One way to always do that for the purpose of this topic is to multiply by a number. In this case, that number will be 2. Well, whatever is good for the bottom of this fraction is also good for the top of this fraction. So this becomes 1 over 14 plus 2 times 2, which is 4 over 14. So you have converted 2 over 7, you have given it an after look, which is 4 over 14, an equivalent form, where both fractions can now share the same denominators, and it will make it a lot easier to add the two fractions to give you 14 on the bottom, since both denominators are 14, and then on the top, we can say 1 plus 4, which will give us 5 over 14. So, the gist we want to make here is that if we can convert a fraction or both fractions to a form where they both share the same denominators, it is always easier to complete the addition or the subtraction. So let's use that big idea in order to help us with a bigger or more interesting challenge. So let's look at this question A. What we quickly observe is that the denominators here at first look are not the same. But what do we observe? 49 minus b squared is very close to b squared minus 49. Do you remember the tip we used earlier? We're going to rewrite this 49 as negative 49 minus b squared rather as negative 1, bring b squared forward, then minus 49, because that is exactly the same thing. Note that if you multiply negative 1 times b squared, you will get this back, and negative 1 times negative 49 is positive 49. But we're not going to do that. We're going to ensure, again, that we're trying to make both denominators the same. So if we can rewrite this part again as -1, b squared first minus 49, it will just be an alternative form of 49 minus b squared that will be more workable with. So let's go on to the next line. So we have 2b squared plus 30b minus 13 all over b squared minus 49 minus 2b squared minus 5b minus 8 divided by -1 into b squared minus 49. With that written, we can proceed to 2b squared plus 30b minus 13 all over b squared minus 49. And we have negative divided by negative. That becomes positive 2b squared minus 5b minus 8 divided by b squared minus 49. Voila! We have exactly the same denominators, and that should make the next part of our problem solving a lot easier, because it means the LCD is b squared minus 49, and we can focus on simply working on the top here. So which is 2b squared plus 30b minus 13, then plus times 2b squared plus times -5b and plus times -8. So with that set, we can combine like terms. 2b squared and 2b squared are like terms, so that gives us 4b squared, and then positive 30b and negative 25b, that will give positive 25b, and then negative 13 and negative 28, that will give negative 21 divided by b squared minus 49. Well, if we factor this further, we should have 4b minus 3 and then b plus 7 divided by b plus 7 and then b minus 7, since this is the difference of two squares. And then we look for common terms. You have b plus 7, b plus 7 cancels out, and so the final answer is 4b minus 3 divided by b minus 7. Now we proceed to the next example. Something slightly different. For the first fraction, we have 6 all over m plus 6 minus the second fraction, we have 12m all over. So for, again, as we're saying, the second fraction, the bottom has the difference of two squares, m squared minus 6 squared. So that factors into m plus 6 times m minus 6. Well, at this point, we need to find the LCD. What you observe is that m plus 6 can divide into this piece. So, just as 7 can divide into 14, and 14 turned out to be the LCD, we can take m plus 6 and m minus 6, the product, to be the LCD. If that doesn't work for you, this is another easier way to consider how to find the LCD of these two different entities. First, there is an m plus 6 here. There is another m plus 6. There is no need to repeat that. Do we have another different component? Yes, and that is m minus 6. So, to construct the LCD, what we did was to pick all the different possible factors from both of the denominators and assemble them together as a product, and we have the LCD. Now that we have the LCD, it is very important that we make both denominators exactly the same. How do we do that? Check out this. m plus 6 times m minus 6 already matches the LCD. So this fraction is already in a good form. It does not need any extra help or extra source. However, you have 6 all over m plus 6. The denominator is missing this component in order to catch up with the LCD. So we can help it a little bit. Let's do that, because by helping it, we are also helping ourselves. So we have 6 all over m plus 6. This needs m minus 6, so we're going to include it and pay the price. As long as we put it on the bottom and on the top, we are good to go. Then minus this guy we said earlier is already in a good form, so we will not adjust or put any extra sauce on it. And this is good. By doing this, what do we observe? Both denominators are now exactly the same as the LCD. That is good news, because it means in the first step towards our final answer, we have m plus 6 times m minus 6. And so, for the top, you have 6 times m minus 6 minus 12m. If you will, you might not need to rewrite all of this. So 6 times m, 6m, 6 times negative 6, negative 36, and then minus 12m. And so we're good to go towards the answer. 6m minus 12m, we have negative 6m divided minus 36 divided by m plus 6, and then m minus 6. And the top we can factor into negative 6 into m plus 6 divided by m plus 6 times m minus 6. So we cancel out the common factors, and we have a final answer, which is negative 6 divided by m minus 6. Now we consider the next example, in which case we have negative 3m over 3m minus 3. What we quickly observe is that the denominator can be factored into 3 into m minus 1. And for the second fraction, we have 5m divided by a bottom that can be factorized. And it can be factorized into m plus 4 times m minus 1. So now that we have all those pieces, we can find the LCD. What are the different elements we have? We have a 3, we have m minus 1, and then we have m plus 4. So 3, m minus 1, and then m plus 4. These are the different or distinct pieces that we can collect from the two denominators together. So with that said, it is time to ensure or to make both denominators look the same as the LCD. Do you think each fraction needs help? I would say yes. So let's begin. Let's help it out. So you have currently negative 3m divided by 3 times m minus 1. Well, you observe that if we compare these two, this particular fraction, to catch up with the LCD, needs an extra m plus 4 component. Well, if we put the extra m plus 4 on the bottom, we must also put it on the top. So we have helped that fraction so that its denominator matches the LCD. Then plus 5m all over m plus 4, and then m minus 1. Does this fraction need any help in order to catch up with the LCD? I would say it needs a 3. So I'm going to put the 3 on the bottom, and I'm also going to use it to multiply the top. So with that said, you will observe that both denominators have the same denominator. And so that denominator is coming in as part of the final answer and also matches the LCD automatically. So with that said, once the denominators match, our focus can strictly be on the top. And so we have negative 3m times m, negative 3m squared, negative 3m times plus 4, negative 12m, plus 3 times 5 will be plus 15m. And then we proceed to combine like terms. So you have negative 3m squared, negative 12 plus 15 is plus 3m, divided by 3 into m minus 1 and m plus 4. And if we observe closely, from the top, we can factor out negative 3m into m minus 1 divided by 3 into m minus 1 times m plus 4. And then we proceed to inspect the common terms that can be crossed out. 3 crosses out 3, m minus 1 crosses out m minus 1, and so we have finally negative m divided by m plus 4 as our remaining components, which form the final answer. Now we proceed to go on to question D. In question D, we have 3 terms. The first term is already in a simplified form. The second term is also in a simplified form. The third term, the top part is already simplified, but not the bottom. The bottom can be simplified or factored into 2b, b minus 5. By factoring the bottom into this simplified form, we are able to easily construct the LCD. The LCD in this case will be b minus 5. There will be a 2b. We're going to write that in front since it does not matter the order. And then you have 2b again. This is the 2b already. b minus 5, that has already been written. So the LCD in this case is 2b times b minus 5. Now we move on to the instance where we start examining each fraction and comparing the denominator to the LCD. This is b minus 5 already, but it needs an extra source of 2b in order to catch up with the LCD. So multiply this by 2b, multiply the top 2 by 2b. Then we move on to the next fraction, which is 3 all over 2b. What do we observe? In order for the fraction or for the denominator to catch up with the LCD, it needs extra b minus 5. So b minus 5, b minus 5 on top and on the bottom. Then, for the last term, you have 2b minus 15 divided by 2b into b minus 5. This already matches the LCD. It does not require an extra source. So with that said, we are good to go because all the denominators have exactly the same components, and that makes it easy to write the next part of the answer, which is 2b, b minus 5, which automatically matches the LCD. And now we can focus on the top. 2b times 2b is 4b squared. Then plus 3 times b is plus 3b. Plus 3 times negative 5 is negative 15. Negative times 2b is negative 2b. Negative times negative 15 is positive 15. So with that said, we are ready to combine like terms. So we have 4b squared plus 3 minus 2 is plus 1b, and negative 15 plus 15 is 0. There is no need to write 0. divided by 2b into b minus 5. And so here we have a common factor of b that we can pull out. And then we have 4b plus 1 divided by 2b into b minus 5. The only common factor that can be cancelled out is b. And so we have 4b plus 1 all over 2 into b minus 5 as the final answer.